You've got a 50-page PDF about. You want to search it with embeddings. But here's the problem: you can't just embed the whole thing as one vector. How you split that document changes everything about whether your search actually works. Why does chunk size matter so much? Imagine searching for how to set resource limits for pods. If your chunk is too large, say 2,000 tokens, it contains resource limits plus networking plus storage plus health checks. The embedding captures the general topic but misses the specific subtopic you need. Too small and you lose context entirely. A 50-token chunk might say set the limits field with zero indication of what limits or where. You need the Goldilocks zone. Let's look at 4 strategies to get there. Strategy 1, fixed size chunking. The simplest approach: split every n characters. Dead simple to implement, predictable sizes, works for any text. But it splits mid-sentence, mid-paragraph, mid-thought. A chunk might start with continued from previous section, completely meaningless in isolation. Strategy 2, recursive character splitting. This is the chain default and your best starting point. It tries to split on natural boundaries, first double for paragraphs, then single, then sentence endings, then word boundaries, and only as a last resort individual characters. It respects natural text boundaries and is much better than fixed size for most content. But it's still purely character-based. It doesn't understand meaning. Related content can still end up split across chunks. Strategy 3, semantic chunking. Now we're getting smart. Instead of counting characters, we use embeddings to detect when the topic actually shifts. We compute similarity between consecutive sentences. When it drops below a threshold, that's our split point. Chunks align with actual topic boundaries and they're semantically coherent, which means better retrieval. The trade-off: you need to run embeddings on every single sentence during ingestion. It's slower and more expensive, and chunk sizes can be very uneven. Strategy 4, document structure-based chunking. Use the document's own structure, headers, sections, code blocks, as natural boundaries. For Markdown, Chain's Markdown header text splitter splits on H1, H2, H3 headers. Each chunk automatically includes header metadata, which is fantastic for filtering. Now let's talk about the overlap problem. Without overlap, context gets lost at chunk boundaries. Imagine the sentence, the default has no resource quotas applied, gets sliced right in the middle. Neither chunk contains the full thought. Overlap fixes this by repeating content at the edges. How much overlap? Rule of thumb, 10 to 15% of your chunk size. For a 500-token chunk, that's 50 to 75 tokens. Enough to preserve context at boundaries without bloating your vector store. So what chunk size should you actually use? The empirical winner for most RAG applications is 256 to 512 tokens with 10 to 15% overlap. But always test with your data and your queries. Here's a quick experiment. Loop through different chunk sizes, search, evaluate relevance, and pick the winner. One more advanced technique: multi-level chunking with parent-child relationships. You search against small child chunks for specificity, but return the larger parent chunks for context. Best of both worlds. The best production RAG systems use this approach. Here are your practical takeaways. Chunking is the #1 lever for RAG quality. Spend more time here than on model selection. Start with RecursiveCharacterTextSplitter at 256 to 512 tokens. Use document structure when available. Always use overlap, and always benchmark with your actual data. Next episode, hybrid search, because sometimes vector search alone isn't enough. Try searching for error code KB4092 with cosine similarity. It won't work. Hybrid search combines the best of vector and keyword matching. Subscribe so you don't miss it.